Welcome to homework.
So we have the question says that there is a particle of mass 10 grams. So let me write that here. M is equal to 10 gram, and in SI this 10 gram is equal to 10 to the power minus 2 kg, and also says that the charge of the particle Q is equal to 10 microcoulomb. So 80 microcoulomb. So 80 microcoulomb, if you want to convert this into coulomb, that will give me 8 into 10 to the power minus 5 coulomb. That is in SI now, and says that the region has a free fall acceleration of minus 9.8 J. So G is equal to minus 9.8 in direction of J. That is now in meter per second square, and says the velocity of particle V. This is a vector quantity, so here I put an arrow there. V is equal to 20I kilometer per second. So let me write this in SI first. It is in kilometer per second, so that is equal to 20,000 I meter per second, right? Okay, and says that this velocity is perpendicular to the uniform magnetic field. And the question is asking us to find out what the magnetic field is. Alright, so let's do that here. The question says that the velocity of the particle is constant, right? So it says that V is equal to constant. Now, for V to be constant, what should be the acceleration of the particle? It means that the acceleration should be 0, right? And if acceleration is 0, that means the net force on the particle F net equal to 0. Now the forces acting on the particle are, one is force due to gravity, and the other is force due to magnetic field. Now if they want to cancel each other to keep the net force 0, so what should happen is Fg should be equal and negative to Fb, right? So this means that m times g is equal to, now force due to magnetic field is what? Q times B cross B, right? So this is our vector quantity, right? So this should hold true. So let me write this, separate the magnitude and vector. So this is magnitude of G into direction of G is what? Minus J is equal to Q times what? Let us take the magnitude of B and B out. Then what is the direction of B? That is I. Okay, so we now need to determine the direction of B. So tell me what thing here will give me I cross that will give me minus J, right? So that is what, if we see the relation between Ij and K, then we know that I cross J equal to K, right? Similarly, if we want J, then I cross K equal to minus J, isn't it? Is it? Yeah, we missed a minus here, so let me add that here, minus. Okay, so what we need is, here I cross something should be equal to minus J, and note the minus sign here. So what would be good here? What would fit in this space here? So that will be minus of k. Now why is that? Because I cross minus k, because we have a minus sign out here, so I cross minus k will be exactly equal to minus j, right? So we can just say that the magnetic field has direction of minus k. So let us remove out the direction terms. So mg is equal to qvb, and if we want to find out the magnitude of b, then magnitude of b will be mg by qb. Now if you plug in the values of mg, q and v, only the magnitudes, okay, then this will give me 0.061 Tesla. Now if I want to write this in magnitude, sorry, in direction, in a vector, as a vector quantity, then b vector will be b. Remember, b is in minus case, so b is equal to minus 0.061 Tesla, but in k direction. So this gives me the value of magnetic field. This is the solution for this question. Thank you for watching.